think too much about it. So, the answer to that, no.
Oh, that's your question.
Now you can see how long this is going to take, right?
I know it's
And here's your shot of the lighting setup. I'm just
Thank
rolling
you.
on this for a second.
Yeah, that's great. So you don't have the CPU anymore? Or is that?
I think one of them's got a CPU and one doesn't.
Oh,
But I haven't had them fired up in years. Matter of fact, that disk unit there's another disk somewhere, but that disk was just unwrapped, literally unwrapped from when it was wrapped at MITS about a year ago. It'd been wrapped for
really?
almost 30 years.
Oh, that's great. So you said, Eric?
Yeah.
We'll start with the easiest question. If you can just introduce yourself to me.
I'm Ed Roberts. Is that it?
Doctor, saint. You can give it to me again. Tell me again.
I'm Ed Roberts.
And tell us why you think we're interviewing you.
Beats me.
Okay, well, let's
I guess this is to get a little bit of the early history of personal computers.
And you were quite a leader in that industry.
I was there anyway.
Yeah, we'll get to all those questions. This is going to be divided up into segments. I'm going to start with your background, then we'll move on to your academics and when you're in the Air Force, and then some specifics about MITS and the Altair,
Okay.
and we'll have some other questions at the end.
Okay.
So, first of all, if you could tell us where you're originally from.
Originally I'm from Miami, Florida.
This is very direct, isn't it?
Well, I'll try to expand on it, but I'm not sure what else I can say.
Yeah, no, that's fine. And what school did you go to in Miami? Did you go all the way through school in Miami?
Went all the way through school in Miami. Went to Citrus Grove Elementary School and junior high. Went to Miami Senior High.
And from there?
From there, I went to Stetson, which is in DeLand, Florida. Went there for a year. Then came back and went to the University of Miami for, I guess, a couple of more years, intermittently.
And what were you studying at the University of Miami?
When I came back, initially I was studying zoology at Stetson. When I came back to Miami, I switched my major, I think, to EE, electrical engineering.
And why did you do that? What was the interest?
I always had an interest in electronics, and I had an interest in medicine, and really the idea at that time was to try to combine the two. And engineering was a very unusual degree for a doctor to have at that point. Doctors just didn't get degrees in engineering. They got in biology or chemistry. So I thought it would give me kind of a different approach to medicine.
And you got your undergraduate degree in electrical engineering?
Undergraduate degrees in EE, right?
And when did you join the Air Force?
In May of '62.
And what caused you to do that?
I was married. My wife was pregnant. I was running out of money, and the Air Force had a program that would pay for the rest of your college if you got qualified for it. So it was a way to finish up my college.
Your undergraduate or your graduate?
Undergraduate.
And so at what point when you were in the Air Force did you start working with the weapons lab? Can you talk about that at all?
Yeah, that was a good bit later. My first 4 years in the Air Force, 3.5 years I spent in crypto school, either as a student or teaching crypto electronics. And then I spent a couple of years in college, getting my degree at Oklahoma State. And then I came to the weapons lab in Albuquerque, and was at the weapons lab the last 4 years I was in the Air Force.
Oh, so that's what took you to Albuquerque.
Yeah.
At that point, well, how long were you with the Air Force then? And then I'll move into that.
All total about 10 years.
10 years.
Yeah.
So you not only finished your undergraduate degree, you made it a career for a while.
Well, once you accept that program, you're obligated to them for a number of years. So I got out at the first opportunity. That I was not. I'd paid back my obligation.
Can you talk about what you were working on in the lab?
Well, I was working on laser weapons at that time. That was secret. They didn't admit they had laser weapons at the weapons lab. even though we had a building there that said laser division, and it was inside of this big complex that said special weapons, but you weren't supposed to be able to figure out that's what we were doing, I guess. I don't know, but that's what we were doing. And I designed the first fire control system for laser weapons. And
where do you think this interest came from you as a young boy wanting to get into electrical engineering? Did you like play with hobby kits and things like that? Put kits together, or?
I like to build things, but I think if I had, in some respects, I'd probably like to be a mechanical engineer. But the problem was with mechanical engineering, if you set out to do anything of any complexity at all, you got to have a machine shop, you got to have milling machine lathes. It takes a huge amount of time to build anything. Whereas electronics with soldering iron, you're in business, and you can just do whatever you want to do. So you can really make complex things with relatively minimal amount of equipment pretty quick. And that was not an option with mechanical things. The kind of electronics I've always been drawn to is electronics that you do basically mechanically. In other words, the design is pretty much a mechanical kind of design. Digital design is sort of mechanical kind of design. But I think that's probably the reason I got into electronics.
Mm-hmm. Did you have like a workbench as a child with a soldering iron?
No, I used to do surgery on animals as a child, but I didn't know.
Really?
Yeah.
Were your parents aware of this?
Yeah, I used to operate on snakes and stuff like that.
So you really weren't into any kits in the early days?
No.
Okay.
I built, and when I was in high school, I built a relay computer. But that was just out of surplus parts that I bought, picked up around.
How did you learn to be able to build that?
Some of that's sort of intuitive, if this closes, that's going to close, and so it just kind of, I didn't really learn it anywhere. I think you just kind of pick up some of those things. There's no great genius there.
Mm-hmm. But no books helped you, or?
I read a lot then, but I don't think I read anything on computers that I can remember.
Mm-hmm.
I read some of the stuff on electronics, but I don't think I read very much on computers.
Mm-hmm. Did your computer do anything?
Made lights flash, I don't know.
Ooh.
That's it. Well, what do you get for a nickel?
Yeah, that's great. Well, I'm kind of jumping all over, but I'm just going to, so none of these questions are going to be in order, Andrew. Just so you know. So were you aware of what people called the priesthood back then, that a lot of these, mainframes were like not accessible to people who were interested and
I thought I was the one that coined that. I used to say it at the weapons lab, we had the largest computer installation in the world. We had two CDC 6600s back to back, and that was by far the biggest computer installation. The thing that always struck me is they had this big glass enclosure, and you have the high priests that walk around and manipulate the machines. And those of us that tried to get data out of it were never allowed to touch it. We had to slide our cards in through a window, and they would check them to make sure they had any fingerprints on them, I guess, and they would load them and tell us to come back in a few days, and they would let us know that what errors we'd made in our cards, where we could redo it again. And that was kind of my model for computers. And I always thought that was a bad way to go. I thought everybody ought to own their own computer, and I thought that for years and years. When I was at Oklahoma State, getting my undergraduate degree, they were one of the really forward-looking schools. And they had an IBM 1620 in their computer lab that you went up and signed up time for it, and it was left on. There was nobody guarding the machine or anything. You could use the computer whenever you wanted. If you could get time on it, stay busy 24 hours a day. But that was your own computer. Now, power-wise, it'd probably take 20 of them to equal the power of the Altair. Or, it was not a very powerful computer, but it was a computer, and you could actually compute things and do things with it. And it was that was another thing that kind of precipitated my views about the big computer sites with the gods in them and all that, or the priests in them.
Mm-hmm, mm-hmm. So, but as a child, were you aware of the priesthood of these big mainframe computers when
Well, big mainframe computers weren't really around much when I was a child. I mean, you got to realize that one of the things that really occurs to me, I have to think about. I always, you think about anything that goes on. You talk about cars; those were made way before you ever came along or ever thought about coming along. But it turns out with computers were still pretty embryonic. Even when I was in high school, this was in the late '50s. There were computers around, but they were nothing like we would call computers today. And that was true up into the '60s. That was an evolving science, and it hadn't gotten there. So I don't think that the idea of having the room with the high priest would not have existed back then, because they didn't have the computer to do it with.
But there's this kind of altruism that goes along with wanting the kind of power for the people. Did you feel that? I mean, you said you felt that people wanted this power, that this computer could make. Did you feel that you wanted the whole world to have that? Or?
One of the things, if I ever write a philosophy book, and I've got a bunch of things I want to put in it, but one of them is that to some extent your worth, talking about financial worth now, is measured by the number of people you control. Okay? Number of people you own, so to speak. In the case of a computer, one person can do the work of thousands of people. So by historical definition, if you have a computer, you're wealthy. I mean, beyond imagination in terms of, say, a few thousand years ago, a few hundred years ago even. And that's always intrigued me about computers, is an enormous amount of power it gives just us regular folks.
How did you come up with the idea of well, first, how did you come up with the idea for MITS? Was it something you came up with while you were still in the Air Force? Yeah,
we were still in the Air Force. We were going to start a company. And there were four of us got together, and one of the guys was in model rocketry. That's Forrest Mims, was in model rocketry. And he said, there's a big need for telemetry equipment for model rocketry. So we set about designing telemetry equipment for model rocketry. And that's where MITS came from. And we didn't sell much telemetry equipment. We learned a lot about making a business. And
what about the name?
Micro-instrumentation and telemetry systems.
Yeah, you could start that over again. I was still yammering on.
Micro-instrumentation and telemetry systems. We decided that was a little cumbersome, and later on it changed it to MITS. But
any connection with MIT?
Oh, the idea was to generate that implication, I think, at the time. I even think that was specifically talked when we had a meeting about us coming up with a name that wasn't MITS. Would have been a good name. But
that's good. When you were in the Air Force, was there any people that influenced you in continuing on in electrical engineering or in business? Where did you get your inspiration, or who did you get your inspiration from?
I don't know. My entrepreneurial inspiration probably came from my grandfather, who was an entrepreneur. But beyond that, I don't know.
You're just a curious child that just wanted to get into a lot of things?
Well, I've always enjoyed being involved in a lot of different things. I still do. And up until this last go-around, I always said you shouldn't do anything for more than about 4 or 5 years, and then you make a radical change in your life. And I did that pretty much my whole life until recently. I hadn't thought I'd think about that more, but
let's see. Can you talk briefly about the priesthood and the big computers? But let's talk about technology in the 60s. Can you talk at all about what was developing in technology during that time period?
Well, the 60s was the point where vacuum tube electronics was being replaced with semiconductor electronics. Or actually, more accurate, the 50s is probably when that technology was being replaced, excuse me, where transistors were replacing vacuum tubes. by the 60s, integrated circuits were starting to replace plain conventional wired electronics. And that was probably the big thing that was going on all during the 60s was the integrated electronics, where you put a number of transistors on one chip. And that evolution continued up until probably the late 60s. There were things that you could call a computer that were on one chip. Now, these were not computers that you could do very much with, but you could see the embryo was there anyway. And it was several years later when the 8080 came out, which was the first chip, I think, that really met all the criteria that you need for a processor. And that would have been in probably in '74 when we first got our hands on 8080.
So were you tracking this technological process all along, and just kind of were you waiting for this chip so you could do something with it? Or?
No, I mean, I think that would be much more sophisticated than what we were doing. We were just watching what happened. If something came along that was interesting, we played with it. And you might sound better to say, yeah, we were doing all this, but we weren't. We were just certainly watching the technology. I'd been working on a calculator at the time we did this calculator, using LSI, or using integrated circuits, just conventional integrated circuits. And when this thing came out, where with 4 chips replaced 80 ICs, it's pretty clear you had to go to that, and that's the reason we switched. And but that evolution that's kind of true of everything you did in electronics then and now, for that matter, is you just watch what's happening and you move along with where the technology's going.
How was it that you first heard of the 8080 chip?
Probably in conversation with the Intel rep. Intel rep had been to a meeting, I think, and had heard that they had this chip coming down. So we started pressing him, and he knew we had done some things that were pretty much new things, like the calculator. And he got us some data sheets, which were handwritten data sheets. There was no published data sheets. And then got us 1 or 2 samples of the 8080, and that's how we got started. But that was before it was even advertised or anybody knew about it. Of course, that's true of most of these things that come out now. Most of the electronics that come out now, there have been a few companies were given access to it before it was announced.
I think Intel is still one of those.
People aren't.
Do you think Intel is still one of those companies?
Yeah, they probably keep a lot of parts that they give. Certain people know about before anybody else does, before it's released.
So your first interaction with a computer, besides the little one that you built, which one was that? The one in...
The first one that would be a general purpose computer would have been that IBM 1620 at Oklahoma State. And I'd done a good bit of stuff before then with analog computers, which nobody talks about anymore. And I probably had done a lot more stuff with analog computers by that time than I had with digital. And that was probably true only up until the end of the 60s. Was analogs were kind of the way I was playing.
So this computer at Oklahoma State, would you consider that a time-sharing computer?
No.
Oh, it wasn't.
It was a standalone computer. And
do you remember the very first time that you ever used a computer? Yes.
no, I don't think so. Nothing jumps out at me.
Did you ever work on a time-sharing system?
Yep.
For our junior high school audience, can you describe what time-sharing is?
Time sharing, you realize computers are much, much faster generally than the user. And unless you're doing very sophisticated calculations, the amount of time it takes a computer to do most of the things that you do are instantaneous for all practical purposes. So what timeshare does is take and divide a second up into intervals. And it says, we're going to let you have this second for 10 milliseconds, or a hundredth of a second. We're going to let you have it for the next hundredth, and you for the next hundredth, so on. Well, since that's so fast, you don't realize you're only getting the computer for a hundredth of a second. But the computer's making, say, 1 million calculations a second. In a hundredth of a second, it's made, 10,000 calculations, whatever that works out to be. But so you can do a lot of calculations in your little tenth of a second. And that's basically what timeshare was. It just went from one computer to one terminal to another. Everybody had their own terminal. Everybody thought they had their own computer, really. But actually all they had was a tiny slice of time out of that computer. And that was being pushed for a pretty good while when the Altair came out. That was what the big word was. The whole world was going to be time-shared. And that's the way everything was going to be done. Anything beyond that was a waste of time. And I didn't think that was, I didn't buy into that either. If you had any application beyond trivial applications, you had too much data that had to be transferred back and forth. And at that time, we considered transferring at 3,000 bits a second as being really fast transfer. And of course now, all kinds of that science has come along too and do a lot faster. If all you could transfer with 3,000 bits a second, you weren't going to do much very sophisticated with a timeshare system.
So you kept thinking, I know, I'll get to this later, but I can start seeing your train of thought. You kept thinking that that wasn't going to be the way. At that point, were you thinking of building your own computer? Or an individual computer?
It never really slowed me down as far as, matter of fact, we had a timeshare system we owned at MITS, and we sold timeshare on it. But I never thought that was going to be the be-all, end-all for computers. I thought that was just an interim step. But at that time, that was a big thing. It was.
We'll talk about some of the other products at MITS, but since we're kind of going in this flow, what then caused you to come up with this idea of building a microcomputer, that time sharing wasn't the be-all, end-all? What moved your thoughts?
I'd wanted to build computers all along. I mean, I'd always wanted to own a computer. And had been kind of playing around with a computer, at least if you count the relay computer in high school, for, by that time, 20 years. So every time something came along that added the capability or your ability to build a computer at home, I jumped on it. So it was kind of a natural evolution. And of course, we had the company at that time with a place to go with a product, and which made it handy anyway. At least you could do something to maybe sell it.
Did you think that you'd be able to sell them?
I thought we could sell it. We had a meeting with the bank. MITS was bankrupt at the time, or essentially bankrupt. And we had the last meeting with the bank before they were going to foreclose on it, probably, if we hadn't. And I told them we'd already gotten the acceptance at Popular Electronics to get the computer published. And we were absolutely straight up with the bank, told them what our situation was. And that to keep going, we needed another $65,000. And the banker asked me, he said, well, how many of these things do you think you'll sell? And I said, I think you'll sell 700 or 800 of them over the next year. And everybody kind of laughed at me, and I was accused of being a wild-eyed optimist and all that. I mean, we had days, a few months after that, we were getting orders for 300 or 400 a day. So I don't know where I was headed with all that,
Laughing all the way to the bank on that one. Yeah.
Well, we went from, this was the time before Billy Carter's friend did away with the overdrafts. But we kept an overdraft at the bank for about $250,000. And we went from an overdraft of $250,000 to about $250,000 cash in our checking account in a period of about a month and a half.
Amazing. Let's back up a bit. Did you consider yourself a hobbyist as a teenager?
No, I was never. I always had too many things going on. I was working in experimental surgery when I was in high school. I worked for a veterinarian several years of that. I taught surgery as a senior in high school. I was always involved in a lot of different things. I was never really a hobbyist per se. Except maybe with model airplanes. I think I did some model airplanes. That was a hobby. But.
So we'll talk about some of we'll talk about the beginning of MITS. Can you talk about the people who, you mentioned 4 people that you started the company with, and then let's talk about some of the products that you created.
the products we made basically were for telemetry, to be able to send back information that told you what a model rocket was doing. One of them was a real simple blinker that blinked at a predetermined rate. And I just have to think about it. I guess by counting the number of blinks, you could tell. I have to think about that now. That is, you could tell how far the rocket had gone, or what the roll rate was, I guess. You could count the blinks and tell what the roll rate of the rocket was. And we had temperature sensors that would detect the temperature at different altitudes. There were all those kinds of things. One G meter measured accelerations. Nothing very exciting, but it was better than just going with your rockets. At least you had something. You got some data back. And
when did you move into calculators?
After I bought out the other three partners, they didn't think there was any future in building a calculator, and who would want a calculator at home. And that's kind of been the story of my life. As a matter of fact, I know I'm onto something good is when everybody tells me this is a bad idea. And I didn't know that then, but I found out since then but they said there was nothing going on with this. And one of them even told me that he didn't have any time to waste on this MITS business. He said, if you really get something going or making some money, give me a call and I'll get back involved. I said, okay.
So you didn't want to help with the grunt work and getting it going, huh?
Well, he would help haul the money to the bank, he said. That's not what he said, but that was the implication, And I've seen that a lot in people. They want to do something, but they don't want to really do the work part of it.
So what was happening in the calculator industry to make you want to start moving in that direction?
Well, there's nothing going on in the calculator industry as far as electronic calculators. Frieden and Monroe, I've got to come back and maybe modify that. Frieden and Monroe had some calculators they sold for a couple $1,000s a piece for a 4-function calculator. But when EAI came out with this calculator chipset, I jumped on it. And it said, we can build us a calculator. And we'd already published some articles in Popular Electronics before then. And like I said, I'd been working on a discrete calculator for a year by that time. So when the EAI set came out, we immediately bought a set, built a machine, and took it to Popular Electronics, and they published it. And that was the first electronic calculator, large-scale integrated electronic calculator, produced in the United States to the best of my knowledge. And,
did you have a large clientele?
For us, we did fantastic. We sold thousands of them. And you got to realize, this is a company who had been in the model rocket telemetry business, and so our numbers were quite modest there. We had a big production run that we made 10 of something. So by being able to make thousands of something, that was a big improvement.
Scott, are we still okay on audio?
Yeah, I think so. Did something change?
He just shifted a bit.
Is it still...
You can do that. I just want him to.
I'm sorry, I want to remove again.
No, that's
Can you
all right.
check back with us occasionally, or should I just interrupt you?
Yeah,
Okay.
anytime. Yeah.
Okay.
If I don't ever move again, will it be okay?
What were the names of the 4 people you started MITS with, and how were you inspired to start your own company?
Forrest Mims, Stan Cagle, and Bob Zeiler.
If you could state that as they were the ones that I started MITS with. List their names, then they.
Okay.
Yeah.
The 4 original partners in MITS were Bob Zeiler, who was an Air Force engineer at the time. He was a captain. Stan, I just said his name, and I can't think of his name.
Kegel?
Huh?
Kegel? Something like that?
Close. Cagle. Stan Cagle, who was a AA working for Aeronetics, I believe. And Forrest Mims, who's become pretty famous writing books. And he was a captain in the Air Force. And myself, I was an Air Force officer also. And that were the 4 I was started it.
Did you
And,
think that?
and what made you want to start your own company?
I think that's you were asking about my inspirational thing. I think since I was pretty young, I'd always been wanting to own my own company. I've never been big on working for anybody else. That's never been one of my things as an ideal way to go through life. And I've always been pretty good at suckering other people into my projects or getting them interested in what I was doing. And,
Well, that kind of leads into your philosophy. What did you have a business philosophy for MITS?
I don't think we had anything that you could call a business philosophy or would be that sophisticated enough to be called a business philosophy. Beyond the fact that the idea was to make a bunch of them and make money. And that was about as sophisticated as it got.
What would have success been at that point? Say, for MITS to succeed, I want to create and sell 5 calculators. Did you think in those terms?
You mean in the calculator business or in the
No, in the beginning with the
in the model rockets? And we thought we were successful when we sold our first one. I mean, that's quite a thrill. You know, when you start a business and particularly something like that, you got to give me that's a fairly speculative business. It's not just that's not the kind of thing you think about. You've heard about people starting their own restaurant and their own, maybe car wash or something like that. But you don't hear many people starting their own model rocket telemetry. So I think the first customer we got was pretty exciting. So it didn't take very much to make us feel good about that.
Going back to the calculators, what happened in the calculator business then? Who were your competitors then after you created yours, and what happened in the business?
Well, once we got into the calculator business, say let's say after the first 6 or 8 months, everybody was in the calculator business. The chips got more and more sophisticated, which meant the external hardware became simpler. If you look inside of one of these things, they're fairly complicated inside. But you look at a later calculator, and it's just a single chip hooked up to the buttons, and that's it. So that meant that anybody that had a garage could build calculators and compete with us. So there was hundreds of people making calculators, literally. And you had to keep cutting the price. And I remember at one stage our cost, I think, was like $38 a machine. That's what it actually cost us to build one. We went to one of the drugstores there in Albuquerque, and they were selling for $19 a complete calculator ready to go. It was like half of what our bill of materials cost was. And I just figured we were just stupid. We just didn't know what we were doing. We must be missing something. There must be some way to build them cheaper. It turned out we were right. That's what our cost really was. And all those people just went bankrupt. As a matter of fact, to survive through that period is almost an accomplishment. That was the time I mentioned we met with the bank. I mentioned earlier we met with our bankers and said we needed another $65,000 to keep going. That was coming out of the calculator fiasco. We were just rapidly going down the tubes with calculators.
Was Texas Instruments one that was one that was surviving?
Texas Instruments survived, and Hewlett-Packard survived. Hewlett-Packard was just doing the high-end calculators. They were in a different kind of business, really. Texas Instruments survived because they had the whole thing. They built the chips, and they had enough financial wherewithal to do. As a matter of fact, Texas Instruments is about the only one I can think of that's still around that was there then. That was building, simple 4-function machines. The Japanese now had been in the market, and they were in the market when we got into it. They were importing some 4-function machines, but they were selling their machines that they imported sold for a lot more than our machine did.
And some of these questions are going to seem redundant, but we'll just get a different take, a different version of some of these stories. So,
okay.
We talked about moving from the calculators then into the computers. What then? I really want to find out what the inspiration was to, at that point, move into creating this. I mean, really, where was that transition in your head?
The thing that, and this is the toughest part to relate to anybody, and I think it was best said by one of our ex-presidents. Those of us that wanted computers, we lusted after computers. I mean, literally, that would be the only way to describe it. The idea of possessing your own computer was just, I mean, there was only one or two things that was more exciting than that. And I wasn't even sure about that, probably. I mean, literally, we really wanted to, you know, the idea of owning your own computer was just fantastic. And even though I was the only person I could find that felt that way up until after we started selling them. But that's the way I felt, the idea of having my own computer. I mean, I'm not sure exactly why. I mean, I can give you a lot of reasons, you know, like the power it gives you and all that kind of stuff. But it was more than that. It was just something about having a machine that could do all that was just exciting. I mean, just you could lust after it. So.
And you weren't the only one, because after you created the Altair, who were the people that were buying?
Oh yeah, they were nuts a lot worse than I was. I mean, there were a lot of folks out there like me. It was amazing the number of people that were interested. And these were not all, they were not all nuts. There were a lot of them were fairly, matter of fact, most of our customers were pretty bright people.
Pretty right?
Bright.
Oh, bright, okay.
Bright.
Yeah. Should we move into the Altair, since
Yeah.
we're starting to go that way? You seem to have a relationship with Popular Electronics and Les Solomon before the Altair came out. Can you describe the situation of how you got the Altair on the cover of?
Right. Forrest Mims' goal in life was to become a writer, a national writer. And so he had made contact with a number of the magazines, and Popular Electronics was one of them. And he was trying to get articles in there. So what I did was work with him or collaborate with him on a couple of articles. I would do the design work, he'd do the writing part, and we got those published in Popular Electronics. I think the first one was a optical communicator, which used infrared, used an LED, used infrared to send to transmit voice over about 300 feet. And we did a number of other projects like that. So we had gotten a relationship with them over the previous several years. Even after Forrest left, I continued to do projects with Popular Electronics. And,
That seemed to be a new method of advertising, getting a cover of Popular Electronics. Did you feel that would, of course, help your business move forward?
yeah, we viewed that as a marketing thing. They were looking for projects that were interesting, would be interesting to their readers to build, something that readers could build and they get excited about. And this project here was a good bit more elaborate than what you would think of as a project for them. And their projects tended to be somewhat simpler than this was. As a matter of fact, I know that the last time we met with Popular Electronics, right before the articles to go to press, Art Salzberg, who was a technical editor, says he didn't think this was going to work. We were casting pearl before swine with this article. It was just way too sophisticated for the readership. The pusher for it was Art Salzberg, who was the publishing editor, I guess the chief editor anyway. And he thought there was going to be a future in personal computers. And that's probably what kept the article going, was Art Salzberg's support for it.
Tell us.
I'm going to stop and change
Okay.
tape.